Hello everyone, in this video I am going to show you implementation of Ith Order Statistic in worst case linear time. Firstly, I will tell what is Ith Order Statistic algorithm. For a set of n distinct elements, Ith Order Statistic is ith smallest element of that set. For example, for I equals to 1 it's a minimum of the set, and for I equals to n it's a maximum. For I equals to n divided by 2 it's a median. Now let's take a look at our algorithm presentation step by step. At current slide there is input array with 12 elements from 1 to 12. Elements are indexed from 0. For example, array of 0 is 12 and array of 5 is 6. In first step we divide input array to subarrays with 5 elements, and the last subarray has remainder of last elements. Here last subarray is composed of 2 elements. In next step we sort each subarray. Then we take median of subarrays and make new array from them. Here medians are 8, 3 and 9. Next step is either recursively call first step or take median of array of medians. If last array size is less or equal to 5, we take median. If number of elements is greater than 5, then we divide them into subarrays of size 5 and call algorithm recursively. Here array of medians has 3 elements, 3, 8 and 9. So we choose its median, which is 8. Next step is partition input array around chosen median of medians. It's same partition like in Quicksort algorithm. First step of partition is to swap 8 with the last element, which is 9. Then we compare each element to median to group them into 2 regions. On the left are less elements and on the right greater elements. More specifically, in step 2 of partition we use 2 counters, I and j, which are pointing to first element of an array. If element at the j position is lower than the median, 8, then we swap ith and jth element and increment them both. Otherwise we increment only j counter. Here we incremented j 3 times, since 12, 11 and 9 are greater than 8. Now j points to 4, which is lower than 8, so we swap ith and jth element and increment both. Now again we swap 5 with 11. We repeat this step until j points to element before last. Last step is to swap last element median with first element that is greater than median. In our example it's 11. Now we check if ith order value is equal to 8. If so, our ith order statistic is 8. If it's lower than 8, we take array composed with elements left of 8 and repeat the whole algorithm. If it's greater than 8, we take array right of median 8, subtract 8 from ith order and repeat algorithm on taken subarray. Now let's take a look at the implementation of algorithm. I use Visual Studio and project is a C++ console application. We begin main function with definition of ith order statistic, which is 5. Then we define input array, which is a vector of 29 integers. It's important that they are distinct. In next line we call 5 order statistic function on input vector. Let's see definition of a function. This function is a template function with type t, which is required to be comparable. Comparable is a concept that t-type supports comparison of elements. First, we initialize at ith element variable to 0. Then we check if ith element is in a load range. Then we define L and R sentinels. L is left end of an array and R is right end of processed array. At the beginning, L and R defines whole array. Next we have main loop which iterates while L is less than R. First step in the loop is to select median of medians of input vector, part defined by L and R. Let's take a look at select function. If number of elements in subarray is greater than 5, we define the vector of medians. Then we divide subarray to 5 element groups, sort them, and push back their medians. Next, we call select recursively on array of medians. If input array length is at most 5, then we sort it and return its median. After select function there is a partition function. Let's see its definition. It takes as a parameter input vector as a reference, left and right boundaries of a process subarray, ith element which is 5, and a median returned by select function. First we find index of a median and swap median with last element of a subvector. If left equals right, we return it. Then we are doing partition of subvector. Last step is to swap median with I element, so left of median are elements lower than it and right of median elements greater. We return index of a median in process subvector. Next we check if ith order, which is 5, is lower than length of left subarray of a partition. If so, we narrow down process subvector to left partitioned vector, elements lower than median. If it's greater, we narrow down searching to right subvector, elements greater than median. Else, ith order is a median element. Last thing in main function is to print median to console. If we run program, we see that 5th order statistic is a value 5, which is true. That's all. Thank you for watching.